So I just want to take a moment to make a quick video for everybody to know how to properly set up an ESD workstation. ESD is obviously electrostatic discharge, and while most of us may be aware of it, some of us may be not, and it is something that is obviously very important when we work on our electronics. When it comes to working with like integrated circuits, whether it's CMOS, TTL, anything, really, everything is generally susceptible to ESD. And whether you see it or not, ESD is something you can see, smell, hear. And with that said, many times ESD will happen without you even knowing. And there's going to be, more often than not, there's going to be loss of overall lifespan on whatever said chip you're working on or chipset. So I just want to go over quickly what a proper ESD workstation kit would have. So this is a kit made by Statico. It is meeting the ANSI ESD standard S20.20/2007. And this one comes with a 24-inch by 48-inch by 0.125-inch static dissipative mat with a 3/8 inch or 10mm male snap installed. I will show you that in 1 second. It comes with obviously the mat itself and also a banana receptacle as well that plugs in from the corner of the snap of the mat, and it grounds itself to the wall. So this one does not come with a grounding strap, so I had purchased one just for the sake of the video to show you. I also have my own, but I needed to get another. So what I want to show you is, this would be an example of an ESD wrist strap. I also have another one that is like this one. Now this one is a little bit better of a build quality, and they all need to have one of these snaps right here, which would end up with one of these banana plug receptacles right here, which would plug into the snap of the mat. Now every wrist strap should have some sort of resistor in this portion right here of the ESD wrist portion. And the reason why you have that resistor is so when there are spikes of ESD, it protects the electronic from having that charge. This one has a 1 mega ohm resistor. You can test it if you want by using a multimeter and setting it to the 20 mega ohm resistance. If I could show you right here. So you would have it set to 20 mega ohm right there. Since this has 1, which you could do, so you could have it set like that. And you should be able to, wait, see if I can get it in there real quick. Hold on. See if I can get this quickly to be in shot, at least. Maybe this is not going to work. Hold on 1 second. Well, my multimeter is giving me some issues, so I'm going to have to figure that out in a bit. But you would just test the resistance on the resistor that's inside here, and it should come out to about 1 mega ohm. This one is rated for, it looks like, say 9030, so I was pretty close. At least by memory, I thought it was 1 mega ohm. So I'm going to show you real quick what it should look like. So you would have, for instance, let me get this on here real quick. So you would have your ESD wrist strap, and you would put that on just like that. And then you would take your banana receptacle right here, and you would plug it into one of the two available banana plug receptacles, just like that. And this wire that comes off of it, which is on the snap right there, it's going to be running all the way to the screw right there, which is also part of the ground. You can also use another one if you have a banana plug portion instead of this screw type, and you can use it to plug into the wall itself. I will show you that. And this is what that looks like. So you can obviously see there's two dummy parts right here for the positive and the negative. And then the grounding portion is all that is available. And you plug in your banana plug into here, and you can use that as a more, I guess, solid ground to the wall instead of the one you have. So basically, you're completing a full circuit. You have yourself grounded to the mat, and the mat grounded to the wall. Now, that doesn't necessarily mean that every single setup is going to be completely grounded. For instance, my house has wiring from the 1940s and 50s, so not everything is properly done. Now, you can always purchase something like a kilowatt, and you can plug that into your wall, and it will tell you if there's an open ground. It will tell you if it is properly grounded, and if it is properly grounded, that means that the ground in your house wiring is grounded to earth ground, which would be the absolute best, of course, and how it should properly be set up if you want to have a complete full potential for ESD safety. The wall that I'm plugging into right now, I tested it yesterday and it is not, but I will run a ground from another plug so I can actually at least have a proper grounding station area for my setup. And the last part I really wanted to cover was testing how much ESD can be charged up in any given common situation. So if you have the negative lead of your multimeter and you plug it in to one of the banana plug receptacles available, for instance, or you touch it to ground and you have that there, and then you take the positive lead and you touch it to your finger, you can see I'm generating 1.1 volts. Now let's say, you're on carpet, and carpet obviously generates more, and a lot of us have carpet. So you want to start moving around, and you can see that it jumped up a little bit. Now if I had no shoes, of course it would be more. You generate more, and I tested it yesterday, and I was up to 2.2 volts or something rather, and all that makes a difference. If for any reason there was a spike in ESD, and let's say 2.2 volts or higher, or whatever it spikes to is beyond what the chip is capable of, any voltage that it does not need is going to affect its overall lifespan in general. So that is just one quick thing I wanted to let you know, that in any given situation, ESD is present for the most part, and it's just a very important topic that I feel like everybody should be aware of. So hopefully this video was at least helpful to you. It's a little bit hard for me to describe it when I don't have many visuals to show, but maybe I'll make another video another time and get a little bit more in depth of why it's also important, and see if I can show you more pictures or examples at a chip level. So thank you for watching.